All right, so we have a graph that's a hyperbola with the equation of x squared over 25 minus y squared over 49 equals to 1. It says sketch the asymptotes, then give the foci, domain, and the range. All right, so it's telling us this is an asymptote, but if I just said to graph, how would you determine if it was a circle versus an ellipse versus the hyperbola? Well, remember with the hyperbola, either the x squared or the y squared term would be minus, and because there's a minus sign between the x squared and the y squared term, it's a hyperbola. Okay. So the equation is equal to 1. That's what we want. If it was not equal to 1, we will have to convert. Now, um, we want to find its center, first of all. So we can start from there, from the center, and then graph. So this x squared and y squared, we could write that as x minus 0 squared and y minus 0 squared. And so that our center is 0, 0. Okay. Now, how do I determine if this equation, if it will be horizontal or if it will be vertical? Well, let's look at the first term of this equation. It's an x squared. Okay. So this is the notion that this equation is a horizontal hyperbola. So it's going to open up left and right. Okay. So now let's find our a squared and b squared. Whereas with the ellipse, to find a squared, you had to find the highest number. Well, for our hyperbola, just go in the order that you see it. Our a squared is 25. Therefore, a is going to be 5 plus or minus 5. Now, actually, we can stop there. We don't have to find b squared because since this is a horizontal hyperbola, our vertices will be at positive 5 and negative 5. So that means we're not looking along the y-axis here. Okay. And remember, we talked about um, transversal axes of a hyperbola, and we talked about the conjugate axis of a hyperbola. Well, this will be the conjugate, the y-axis, because there's nothing that's going to be drawn left and right there. So here we have our center at 0, 0. I'm going to put C there for center, and then we're going to move 5 units to the right. We're at positive 5, 0. We're going to move 5 units to the left at negative 5, 0. Okay. So then it's asking us to find the foci. Now the foci, would think of the Pythagorean theorem, a squared plus b squared equals to c squared. Now this is different from the ellipse where it was a squared minus b squared equals to c squared. So our a squared is 25, our b squared is 49 equals to c squared. At 25 and 49, we have 74 equals to c squared. And we're going to take the square root to both sides. And we have c is equal to plus or minus the square root of 74. And now remember that the foci will be on the same axis as your vertices. Okay. Now, if we want to find the exact the approximation for the square root of 74. Let's go ahead and find that. We're saying uh, we have here 8.6 plus or minus. That's the approximation. Okay, so well then we will plot that over. I'm going to draw that, make it orange. 8.6, so plus or minus, and put F here for the foci. So it's facing in the direction as to how we're going to open and close this hyperbola. Now to find the asymptotes, okay, let's go ahead and just identify b squared for a second. B squared, which is 49, therefore b is going to be plus or minus 7, okay. To find the asymptote, let's go back to your notes. The asymptotes can be drawn by starting at your center, h comma k, and using slopes m is equal to plus or minus b over a. So we need to find b and a. That's why I had you to find um, our b squared and then b. So to find the asymptotes, we're going to use the slope form. Now, every textbook um, teaches it differently, and I think this is probably the easier way to find the asymptotes. And to find the asymptotes, what we're going to do is create what's called the box method. Okay, so we will draw a box that has the slope of the asymptotes. When you draw and extend the diagonals of the box, you will have the asymptotes, which will then allow you to draw the correct shape of the hyperbola. So what's going to happen, we're going to be creating 4 points. A box where we have the center here, and then we're going to be creating 4 points, and then we're going to connect and create 2 lines that will be our asymptotes. Okay, and then it says which will then allow you to draw the correct shape of the hyperbola. Okay, so our b here is 7. We can say plus or minus 7 over 5. Okay, so that means we already know how to use the slope. Either we're going to go up or down, left or right, as far as the rise over run for our slope. So now let's go ahead and from the center, we're going to go up 7 units, and then um, we're going to rise 7. We're going to run 5, and then go in the opposite direction. We're going to go down 7, and then to the left 5 units to the right, and then vice versa. Okay, so let's go up 7. 1, 2, 3, 4, 5, 6, 7, and over 5. 1, 2, here we go, 3, 4, 5. Okay, then we can go down, and we can go back up, and then this time to the left, go up 7 units, and then go to the left 5. Okay, and then from the center, we're going to go down 7 units, and then move 5 units to the right. And then we can do the same thing, go down 7 units from the center, and then to the left. And the reason why I'm doing this here, so you're saying, well, how am I getting these 4 points? Well, we can write this, our asymptote, the slope component, m is equal to plus or minus 7 over 5. You can say plus 7 over 5, positive 5. We can say plus 7 over negative 5. We can say -7 over -5. And we can say -7 over +5. Those are the four possible solutions. Okay. So the so what's going to happen, I'm going to draw a dotted line, is going to create a box. Okay. And then we're able to, what's going to take place, we're going to connect those boxes where, let's see if I can find a straight edge so we can make our line. So you're going to create an X and we're going to extend that out. These are our asymptotes right here. Okay. All right. So now what's going to take place? We're going to add our vertices. We want to draw the shape and see what's going to happen. Our hyperbola here is going to it's going to not touch at the asymptotes. It'll get close to it, but it will not touch. So there we go. We have our foci, and we have our asymptotes. These are asymptotes right here. And this is called the box method. You know, finding the to find the asymptotes. Okay, and then excuse me, our domain and range. So our domain, let's answer that question. Domain, we're looking from left to right. So we're going here from along the x-axis from -infinity to 5, union, +infinity, and that should be -5. Let me write this over again. Okay, -infinity to -5, close bracket, union, +infinity to, excuse me, +5 to +infinity. And then our range is from -infinity to +infinity. There we go.